Welcome to Raw Perfect classes. In this class, I will discuss about artificial intelligence and I will discuss topic propositional logic. So, just before that, there are two aspects to semantics. One is what do we mean by whatever we are expressing, and second, what is you can call truth functional semantics. Truth functional semantics. By this, we are concerned with truth values of statements. Truth values of statements. So, we said that we are looking at classical logic. Classical logic or truth value logic. In our case, every sentence will be mapped either to a value true or value false. So which we could also write as true or false, or we could write as I 1 comma 0. 1 comma 0. 1 means true, 0 means false. So basically it is a two valued set, one of them which we interpret to stand for sentences being true and other stands for sentences being false. Now, when it comes to syntax of language, we need an alphabet. From this alphabet, we construct a set of formulas or sentences. We often use the term well-formed formula. So, it is conventional to use the word formula as a plural, though their order style used to formula. Doesn't matter, we will use the term formulas. So this is what we mean by the term formula. When we say formula mean well-formed formula, when we say formula means well-formed formula, which basically means that a word in the language that you are trying to define. When it comes to reasoning, when it comes to reasoning, we will basically mean inference, which we can interpret, which we can interpret as saying that what else do we do know. So basic idea behind this whole effort is that given that you know some things, you know some facts, what else can you say that you know. So we saw the example of Socratic argument. Socratic argument of syllogism. In the examples earlier where we said that if we know that all men are mortals, if we know that Socrates is a man, then we also know, even though it is not stated that Socrates is mortal. So that's kind of reasoning we want to do. And we will see that reasoning can be of different types in some places. You are sure that what you infer is true in other places, it may not be true. We also mentioned that there is a whole family of languages which logicians have defined, and they differ in how much do they allow you to express. But the basic unit of logic is something called as sentences. So as knowledge base is a collection of sentences. Knowledge base is a collection of knowledge base is a collection of sentences. Now, another thing that I should probably highlight at this very moment, that whenever we talk about reasoning, we are dealing with only syntax. We are dealing with only syntax. Any computer program that you write is a synthetic entity. Synthetic entity. Any computer program that you write is a synthetic entity. It looks at a certain pattern according to rules that you have written. It produces certain new patterns. It does not look at the meaning at all. And we will see that we will associate the word reasoning with proof procedures, because we are interested in automated reasoning, because we want computer programs to do the reasoning for us. We will be interested in those approaches or those algorithms which can be implemented over these logic systems. So at the beginning, maybe today sometime, I will show you that there are proof methods which are difficult to implement in algorithms, because they involve making guesses or making choice, which is easy somehow for us to do at this point, what it's not easy to put down in an algorithm. So as we go along this course, we will sort of oscillate between the representation and reasoning. Now, what is representation? Representation. Representation is our concern as to how can we represent what we really mean or what we want to say. How expressive the language is, how can we represent complex facts, whereas reasoning is concerned with the proof procedures or algorithm which we will apply on the representation. So when you look at the kind of domain of logic, there is a whole class of people who are, you may call as heuristians, mathematicians, logicians, who are not so much concerned with representations. So they will assume, which you somehow they tell you this is the language, and somehow you represent what you want to say in the language. But they are concerned with reasoning and things like you know whether algorithms which terminate, whether everything can be inferred, completeness that we mentioned. Whereas somebody who might be wanting to develop applications, you would also be interested in representation. So how you can represent what you want to represent. how, what to, want to represent. And we will see that that's quite involved subject. It's not straightforward to represent all kind of things what they can express in English. And as you can say, it is Hindi, Punjabi, etc. For that matter are very expressive languages. You can say a lot in that, but also it's difficult to interpret, too difficult to parse. So you must have encountered situations where you must have ambiguous sentences which are not very easy to parse. So let's look at what we meant by the reasoning at a very high level. So what we have is knowledge base. So we use the term knowledge base, KB. For the knowledge base is a set of sentences. So when you say a set of sentences, we also mean in some language. And why we will define shortly what do you mean by language. We will start by defining syntax of propositional propositional language or propositional logic. So this kind of corresponds to what we know. When I say word, we are basically saying that there is a single agent, and in fact we are basically reasoning on the behalf of single agent. So whenever we say there is a certain sentences in the knowledge base, we are saying what does the particular agent know. And now we can kind of represent a knowledge base by set, and it has a set of sentences in that case. Now the semantics says, now the semantics says that whatever is inside this is true. So when you say that you have a set of sentences, then you are assuming that what is given to you is true. So if you have this sentence, for example, S1, S2, S3, S4, etc. So on, you are saying that what else is true. Then in the reasoning, what are asking is what else is true, and that's what we said, right? What else do you know? The term we use is entailment. Here we use term entailment. And we want to ask in general whether a given sentence alpha. So given a set of sentences which we assume to be true, entailments define a set of sentences which also true as consequences, as results which are necessary true as a result. That's what we had said. That's the notion of entailment, whereas the reasoning is concerned with the proof procedure. The question asked is alpha probable? And when you say probable, we will say by our proof method. You can say that, for example, you have given S1, S2, S3, S4. These are the set of sentences. Set of sentences in some language. And if these are true, that is semantics. True entailment implies is alpha true necessarily, and syntactic proof or you can say formal depends upon form is alpha probable? By our proof method, it can be derived by the logic machine. Now, what is the difference between why true we mean something is necessarily true as a result? We will define this very shortly. When we define propositional logic, we will see what does this mean in that context. And this I am talking at a very general level, but uses a semantic notion. So if we know fact A and B, A, B, C, D, what else is true as a consequence of that? That's the notion of truth. So it's a semantic notion, whereas proof is syntactic notion, which says that you write an algorithm and which will take a given fact given to you. You have a fact named fact A, B, C, D. What else will be the program produce? So program is just a program which will look at what it has and applies some rules, as we will see, and produces some new sentences. So this production of new sentences is a syntactic process, and we refer to that as a proof. And we will see that what will be the condition that we will put on the proof, what conditions, what constitutes a proof, what make a proof or a proof. Will look at these things shortly. And so it's a mechanical process. The process of generating proof is a mechanical process in the sense, and you don't look at the meaning of the word, you only look at the form of relation between words. And as we go along, I think this will become a little bit clearer. So we start with the simplest of all type of languages, which is a propositional logic. So first we define a language. What is a propositional language? What is a propositional language? And differentiating features about propositional language is that sentences are atomic. In these sentences, atomic, we can't break down a sentence any further. We can only treat it as a atomic entity. Its atomic unit which is defined in this language. So any sentence you want to reason about will be treated as an atomic entity. So for example, if I want to talk about sentence all men are mortal, then in propositional logic I will say that this corresponds to a sentence and I will call P. So we will be working, as we will see shortly, with propositional symbols or propositional variables which will stand for sentences. It is up to us what we want to plug in into P, but as far as propositional language is concerned, one sentence is denoted by one atomic variable. On the other hand, on the other hand, when you look at first order logic, here you can see that all men are mortal. Here it is represented by P, and this is one first order logic. That means all men means for all X. Man X is implies mortal X. means all men are mortal. For this, for the moment, you can simply say that we are differentiating between categories of things called man and or humans. Category of things which are called mortal. This is a category of thing. This is a category of thing that is mortal. And all we are saying is in this expression is that for all x, for all x, so this symbol stands for all x. This symbol stands for all x. If x is man, then x is mortal. This represent to then. So we are stating that same sentence in first order logic, what we have broken it down into parts, and you can see once you break down things into parts, we can reason with the different parts. In fact, that what will allow us to eventually relate to fact that because Socrates is also a man, then Socrates must be mortal. But in propositional logic, we find that would not be possible. So this is a key feature about propositional logic. What you think, what you can think of, these are propositional variable, which means that we will build our logic assuming that these are propositional variables. But you are allowed to plug in anything in that. So instead of plugging in an English language sentence like this, you could have plugged in a first order sentence like this into this symbol P. Because it's propositional variable, you can plug in any sentence in any language. So whatever the learn from propositional logic, it will be carry forward to first order logic and other logic. Now you can say that sentences are atomic, and in proposition or statements, it is in principle which can be true or false. In sentences can be true or false. For example, a sentence like all men are mortal is a proposition. This sentence is a propositional sentence. But if I say something like sky has 10,000 stars, then if I say something like let's look at the example. So what did he score? I'm not saying this is a sentence. We will look at each of these in a moment. One last one, some random sentences. So sentence or some statements in principle can be true or false. We are not really concerned if they are true or false, as long as they can be true or false. So we call it as a sentence. So first one, we should be keep in mind that if we say that sky has 10,000 stars, obviously it is a sentence because it may be false, but it's still a sentence. It can be principle in a principle true or false. So that's why, but other three are not sentences. But did he scores is not a sentence. It's an interrogative questions. It's asking something. It's a questions. How many scores of you? And that is the questions. And please give your address. This is also a sentence, but it is not a propositional sentence because it is a question sentence. We cannot assign a truth value to this. So that's why every sentence is not a propositional sentence. So that's why that's not the sentence. Every propositional sentence is a proposition is a sentence, but every sentence is not a propositional. What about the last one? If the earth is flat, then you yell, it's a yok. Okay, it's also command of course, it's based upon, it has a part which you can see as a sentence if some statements are true. But on the right hand side, but we sometime we can say it is imperative sentence. For example, if you give you order, open the door, close the door, this is the imperative sentence. So this is not is also not a sentence. So anything which in principle can be true or false is a sentence. Okay, so now let's go to the syntax of our language. So in other words, you can say propositional logic that we are talking about. So some people uh, distinguish every language by two parts. One is logical part, and by logical part we mean say something which belongs to every logic, every propositional logic in this case. Okay, we are talking about alphabets. At this moment, every language has an alphabets. Alphabet has two parts. Logical part which includes propositional logic things, and sometime in these brackets in the principles. Enough you could also add square brackets, curly brackets. It improves the readability for us. So you can say that syntax of propositional logic include alphabets, parentheses, square brackets, curly braces, perpendicular, well, etc. These are the logical parts. Now, true, false, 1, 0, and, or, implies, equal to, XOR, implies, bidirectional, biconditional, and all these are the logic parts. Non-logic part, non-logic, non-logical part, that is colon curly braces. For example, in set, for example, in set P Q R, a countable set of propositional variables. We also use things like P1, P2, P3. So Pn. So all these constitutes alphabets of propositional logic. At this point, maybe I should point out the given language may choose a subset of connectives. So for example, you might see somewhere in notions, if you see L, that is represent to language. Then they will specify what are connectives you are using. So for example, this could be one language which is using three connectives. Three connectives like and, or, not. So you can define a language by choosing which set of connectives you will use. For example, about for 200 years ago, uh, people were trying out different experiments. They are trying to see which set is good set to use, and which we will see shortly what do you mean by this sentence. Okay, so I will stop here in I will discuss next points in the next video. If you like this video, please like and share my channel with your friends, so that they can take benefits from these videos. And this is the first part of artificial intelligence. Thank you.